Hi everyone. Now we can discuss one more problem regarding the rivet design. I can read the question. Please listen and try to write in your notebook. Design a double riveted butt joint with equal widths of cover plates to join two plates of thickness 10 mm. The allowable stress for the material of the rivets and for the plates are as follows. For plate material in tension, that is sigma T is equal to 80 megapascal. For rivet material in compression, sigma C is equal to 120 megapascal. For rivet material in shear, tau is equal to 60 megapascal. In this question, they are asking about the double riveted butt joint, but the figure is already given in the question, so we can write the question and draw this figure also. This is a butt strap joint, and it is double layered butt strap joint. We can write the given data after drawing this figure. Thickness of the plate is given, that is equal to 10 mm. Sigma T is equal to 80 megapascal. Sigma C is equal to 120 megapascal, and tau is equal to 60 megapascal. These are the given data. Now, according to our design pattern, the first step is a type of joint. Here, the question itself they are given. It is a butt joint, double riveted, double strap. That means the value of n is equal to 2 because it is double riveted joint. Then, it is assumed to be chain riveting. We have two types of rivet. First one is chain rivet, another one is zigzag rivet or staggered rivet. We can consider this as a chain riveting, and we can take the values for n1 and n2. Here n1 is equal to 0 because the single shear value is 0. There is double shear will occur here, so n2 is equal to 2. Then second step, the thickness of the plate. What is that value? It is already given in our question itself, so we cannot use any other equations. Directly take the value T is equal to 10 mm. Then, according to step 3, we can find the value of diameter of rivet hole. That means from page number 81 and equation number 5.11d, the value of D is equal to 6.325 root. Here the T is the given value, so we can write it as 20 mm. Then we have to convert it into standard using table. Thus we will get D is equal to 21 mm. Then the diameter of the rivet will become less than actual hole diameter. That is equal to 21 minus 1, that is equal to 20. That is the conclusion of third step. After that we have to find the value of pitches. How we can find the value of pitch? There are two values. First one is optimum pitch and second one is maximum pitch. The optimum pitch will get from the equation 5.12a on the table page on the data book, page number 81. That is P is equal to N1 plus 1.875 into N2 into 5d square tau divided by 4t sigma t plus d. Here all the values are given, so we can directly calculate the optimum pitch. The value will become 118.41 millimeter. The next one is the maximum pitch. In our data book, on the next equation, that is 5.12b, on the page number 81 itself, they are giving Pmax is equal to K1T plus 41 mm. Then what is the value of K1? We will get this value from our data book table 5.4a on page number 85. It is a double strap butt joint and 2 rivets per pitch. So the value of K1 will become 3.5. If we substitute these values in this equation, we will get Pmax is equal to 76 mm. Then how we can standardize the value of pitch? The standard value of pitch is lower value of above two equation. Which one is lower? That is the maximum pitch. Therefore, we can take P is equal to 76 mm. Then step 5. Step 5 is a transverse pitch. That means the distance between rows of rivet. For a chain riveting, it is that is PT should greater than or is equal to 2D. Then D is the value we already calculated. Thus we will get the transverse pitch is equal to 42 mm. It is already given. That equation is already given in our data book, page number 82 and equation number 5.14a. The next one is strap thickness. Again, from our data book, page number 80, equation number 5.4c, they are given strap of equal width have ordinary riveting. TA is equal to TO. That is equal to 0.625 into T. That value will become 6.25 mm. Next one, that is the seventh step is the margin value. How we can calculate margin value? It is already given in our data book, page number 83, equation number 5.16. That value is equal to 1.5D. Here we already know the D value. That value is equal to 31.5. Then last step, that is the efficiency. How we can find the efficiency? That is the least value of eta T, eta S and eta C. What is eta T? That is the tearing or plate efficiency. We will get that value from eta T is equal to P minus D divided by P. If we substitute all the values, that is the pitch value, diameter, we get that is equal to 72.64%. Then next one is shearing or rivet efficiency. Again, from data book, page number 81, equation number 5.9f, we will get eta S is equal to N1 plus 1.875 N2 into pi d square tau divided by 4 pt into sigma t. Here also all the values are given. So we can calculate that value. That will become 128.2%. That is much more greater. Then crushing efficiency. What is that value? PC divided by P, or the value of PC is already given in our data book. N1 Ti plus N2 T into D sigma C divided by PT sigma T. That value is equal to 82.90%. Among this, which one is lesser? The eta T is lesser. That is a value 72.64%. So we can take that value 72.64% is the efficiency of this particular rivet. Thank you.